Okay. So our lesson today is about applications of rational equations. So essentially, we're not learning any new math. We're just applying what we learned last class to word problems. So there's not really like any more difficult math concepts. It's mostly just learning how to take the word problems and convert them into equations. So the way that I want to do today's lesson is I want you guys to open up your homework and look through the questions and let me know which ones you guys would like my help setting up. Because you guys already know how to solve the equations and how to get the solutions because we did that on Monday. But I want to go over any questions you guys have on how to set up the equations from the word problems. Yeah. Yep, totally. All right. So on question 1, it says one number is 5 times another. The sum of their reciprocals is 24/5, but you guys probably have different numbers. And then we're asked to find the numbers. So the things we're looking for are 2 different numbers. So what would you like to call them? It doesn't matter what you choose.
Like X and Y.
Perfect. All right. So we're trying to find the numbers X and Y. These are unknown numbers. And now we're going to go back and look at the information we know. So the first thing we know is one number is 5 times another. So let's have this number be the X number and let's have this one be the Y number. So how would you write an equation from that piece of information? Close, very, very close. It's not plus. It'd be equals because a number is, and like is means this is that, which is like an equal relationship. So we have X equals 5Y. And then the next piece of information we have is that the sum of their reciprocals is 24/5. So we could write X as a fraction if we put it over 1. And what would be the reciprocal of X? Perfect, yep. So I'll have 1 over X. And what does sum mean? Addition. So essentially, I'm going to have both of their reciprocals. So the reciprocal of X is 1 over X. The reciprocal of Y would be 1 over Y. And the sum of them means that you're adding them together. But that's not all of the information from that sentence. What else do we know from that sentence? Perfect. Or in my case, it'd be 24/5, but you guys might have different fractions. Does that make sense how we got those equations from there? Now, this isn't going to necessarily be super helpful the way that it's written right now for finding X and Y because both of these equations have 2 variables in them. So an easier way to think about this would be to say, okay, well, if X equals 5Y, then I could rewrite this other equation as 1 over 5Y plus 1 over Y equals that fraction. Because like if X equals 5Y, then I can just replace the X with a 5Y. Then this equation will be pretty simple to solve based on what we did last class, because you just say, okay, well, the thing I need to multiply by to get rid of my denominators is 5Y, because 5Y will cancel out this denominator and this one when you multiply both sides by it. So you'd go through and do that, solve for Y. And that's just going to be one of your answers because ultimately they asked you to find 2 numbers. But once you know what Y is, it's not too hard to find X because X equals 5 times Y. So once you know what Y is, then you just find X from there. You're welcome. Any other questions you guys would like some help setting up? Or you guys can work on this and try a couple problems and then ask the question if you'd like. Yeah, which number? Oh, yeah, totally. So does it make sense where I got the 5Y from and why I want to do that? So then I'd say, okay, well, 5Y times this fraction will just equal 1. 5Y times this fraction, the Y's will cancel out, and 5 times 1 will give me 5. And then at this point, I'll have 5. The 5's will cancel out and I'll get 24Y. And that equation can be simplified because 1 plus 5 is 6. So I'll get 6 equals 24Y. Divide both sides by 24. and you get y equals 6/24. Oh, sorry, my iPad took a second to update. But 6/24 can be reduced to 1/4. So y equals 1/4, which means that x equals 5/4, because x is 5 times y. And so x will equal 5/4, y equals 1/4. And those would be my two numbers. Does that make sense? Yep, because I found out that y equals 1/4 and x equals 5 times y. So 5 times 1/4 equals 5/4. It's kind of like, well, actually, this is basically like a system of equations. So remember when we solved systems, how you could do it with substitution or elimination? Well, you definitely don't want to try to do elimination with this because the x's and y's are in the bottoms of the fractions. But essentially, we substituted 5y in for x, get this equation. We solved that equation, figured out what y is, and then you plug it back in to find out what your other variable is. Yeah, 5. All right, so on this one, it says the sum of the reciprocals of two consecutive integers is 23/132. Find the numbers. Okay, so first of all, what are we looking for? Perfect. Okay, so we're looking for two different numbers. And the things we know about them are that the sum of the reciprocals of these two consecutive integers are 23/132. So that equation is going to look very similar to what we just did, where you have 1/x plus 1/y equals 23/132, right? Because that would be the sum of the reciprocals is this. Does that part make sense? So that's where the other equation is going to come from. So I'm not quite done yet, because this part right here, integers are numbers like 1, 2, 3, 4, or also -1, -2, -3, etc. And so consecutive means they're next to each other. And so if you think about two integers that are next to each other, like 6 and 7, or 8 and 9, or 10 and like those numbers are all separated by 1. So the way we would write that, it doesn't matter which one you decide to be your bigger one, but let's say y is the bigger number, then you would say y equals x plus 1. Because if they're both integers, but they're consecutive, that means that one of them plus 1 has to equal the other one. So then you would basically substitute like we did in the other one, and you would say, I have 1/x plus 1/x plus 1 equals 23/132. You'd set up that, figure out what x is. And on this one, I think you're actually going to have to do factoring. So I'll go through and kind of show what that would look like. So on this one, I have, I need to cancel out an x. I also need to cancel out an x plus 1. And I need to cancel out a 132. So the thing I'm going to multiply this entire equation by is 132 times x plus 1. Because that includes all of the factors from my denominator. When I multiply this by this fraction, the x's will cancel, and I'm left with 132 times x plus 1. So that will look like that. When I take this, multiplied by this fraction, the x plus 1's cancel, and I get 132x. When I do that times this fraction, the 132's cancel, and I end up with 23x times x plus 1. Then I can simplify this by getting rid of the parentheses. So I get 132x plus 132 plus 132x equals 23x times x is 23x squared. 23x times 1 is just 23x. So that's my equation. And since I have an x squared and an x in it, I need to use that trick where you set the whole thing equal to 0 and factor it, and then set each factor equal to 0. Because there's no way to solve this equation when you have x squareds and x's by our regular ways of solving it. And so we need to use that setting it equal to 0 and factoring trick. So I'll let's probably actually move all of this stuff over to the other side. So if I do 23x and I minus 132 and minus another 132x, I don't know what 23 minus those numbers are. Could you calculate that for me real quick? So do 23x minus 132 minus 132. 223. Okay. So I get 223x. I also have the 23x squared, which doesn't change at all. Or is that a negative? I think it should be a negative. Okay. So I have that, and then I also have my minus 132. Yeah.
132 plus 132.
So I was subtracting these two from this side because I want this to equal 0. So I'm subtracting them over here. So it's 23 minus 132 minus 132. Okay, perfect. Yep. So now that I have it equal to 0, now I'll factor that, which looks awful. I don't think you can. I don't think there are any common factors though. What is 20? So like, I guess we'll just have to factor it the long way. So if I take this number and multiply by that, what does that give you? 3030. 3606. Okay, so 3060x squared. The things that multiply together to get 33,060 and add to negative 223. Yeah.
It's the 132 times 2. You subtract it. 23, right?
Yeah, so these two added together would give you 264. And then if you do 23 minus 264, it doesn't equal this? Oh, okay. Thank you for catching that. Yeah, okay, yeah. Oh, and sorry guys, I forgot that you can't read the green ones. Let me rewrite that in a different color. Okay, so we're looking for something that was negative 3060x squared and adds to 241. What's 3060 divided by 3? Or no, maybe do 30. $102. Okay, so that's too big. What if we divide it? 10 wouldn't work. Can you divide it by 15 maybe? $204. So 15 and 204. I don't think that will work either. Yeah, because if one of them was like one of them has to be negative for them to multiply to a negative. What about 12? Can it be divided by 12? Okay, that doesn't work either. When you divide by 15, it gives you 204, but when you divide by 12, it gives you 1530. Okay, well, we're gonna ask Google because I'm tired of thinking of these factors. So So we want to look for factors of 30, 60. So we have the 12 and the 15. I feel like our answer should be between those two though. Wait, when you divide it by 12, is it not 204, but 1020? But, oh no. So we're looking for something that adds to 241. So these two factors are close to 241. What happens when you divide by 255? What's that factor pair? 12? Okay. Okay, so 12 does work because 12 times 255 would give you that. And if we make the 12, if we make the 255 negative, then that should work because 12 minus 255 will give you this. No, it doesn't though. Shouldn't it have a 3 in it though? Because 255 minus,
It's not 3060, it's 3036.
oh, we had this number wrong. Okay, well, no wonder we were having such, okay, well, that explains. So that changes all of the factors. Is that what you told me and I wrote it down wrong? Oh my gosh. Okay, sorry. That explains a lot. Okay, so that means we need to look for different factors then. 30, 36. Okay, so the factors are close to what we're looking for, which is 241. 250. Okay, so we have 253 and 12. Okay, great. All right, awesome. Sorry for mishearing you on that. That caused a lot of confusion. It's totally my bad. Okay, so then those would be your two numbers. You'd factor it out. And so you would get 23x squared. And we want the big number to be negative so that when we add them together, we get a negative. Okay, so it would look like this. Then you split those into two groups. I'm guessing this must be divisible by 23. I don't know what it, when you divide by 23, does it equal 11? This one is a screenshot from this homework. So, yeah. Yeah, I remember this from last semester and we spent a lot of time on this one as well. And again, it's like, you are welcome to Google what the factors are when they're huge numbers like that, because coming up with it on your own can sometimes be tough. And I won't ever give you something like that on your test. Okay, so I think when you do 253 divided by 23, it should equal 11. Is that accurate? Okay, then the next one has a 12 in common, which also gives x minus 11. And so our answers are x minus 11 times 23x plus 12 equals 0. Now, ultimately, we're trying to find a solution to this. We're trying to find out what x is. Well, if this times this equals 0, then one of these two things has to equal 0. So our two solutions are x equals 11 and x equals negative 12 over 23, because those are the two numbers that will make one of these factors equal 0. Now, we only want to find a single x, but we got two results here. So this might happen sometimes. If you get two results for x, go back to the problem and look at what the conditions were. The problem told us that the numbers we're looking for are consecutive integers. Well, this is not an integer. And so even though it works in the equation, it's not the answer to the word problem they gave us, because this number doesn't make any sense in the context of the word problem. Does that make sense? So I would eliminate this option because it's not an integer, and the problem said that the numbers I'm looking for are integers. So I'd say x equals 11, and then I need to also figure out what y is. Well, I said that y equals whatever x is plus 1, and so that means that the other number is 12. And if you want to, you can always go back and check your answer, and you can say, if I do, I like 11 and 12 are 2 consecutive integers, so that's good. And if you did the reciprocal of these two numbers and added them together, you would end up getting that fraction. Because like if you do 1/11 plus 1/12, you'd have to find common denominators. And if you added them together, you would get 23/132. Yeah. 3. Yeah. Yep. So on this one, it says the sum of a number and its reciprocal is whatever fraction you're given. I have 65/8. And we're asked to find the number. So what is it that we're looking for in this one? Yep, and it's just a single number, right? So then we say, okay, so x is the thing I'm looking for, and I know that the sum of the number and its reciprocal is 65/8. So what do you think that equation would look like?
X plus 1/x.
Yep, that's right. Do you want me to finish solving it? Okay. So then to solve it, you would get rid of your denominators and multiply by, perfect. Yep, and that gives you 8x squared plus 8 equals 65x. And so since I have an x squared and an x in there, that means that I have to use my factoring trick and make the whole thing equal 0. So I'll subtract the 65x over, and I get x squared minus 65x plus 8 equals 0. And then I need to factor that. So I'm going to do that up here since I'm running out of room. So I'll do 8x squared times 8, will be 64x squared. And what are two things that multiply to equal 64 and add to negative 65? And they would have to both be negatives in this case because we want them to add to a negative 65. But if you do a negative times a negative, it will be a positive. So I'll have 8x squared minus 64x minus 1x plus 8 equals 0. The first group, it looks like, has an 8x in common, which gives me x minus 8. The second group, what would you want to factor out of that one? Perfect. And then that gives x minus 8 times 8x minus 1 equals 0. And so that means that our, well, I guess I'll write it down here. So this stuff factors out to 8 minus, or x minus 1, 8x minus 1 equals 0. And our solutions will be x equals 8 and x equals 1/8. And in this case, there's no restriction like saying that the number has to be an integer or anything like that. And so those are our two numbers. But why? How do you decide which one to put it? Yeah.
For mine, like, there's a note that says answer either the number or its reciprocal. So
Oh. Oh, yeah, that would make sense. Because that is that number and that reciprocal. That makes sense. They're interchangeable. So I guess you can just choose either one. Yeah. Any other requests? Yeah. Number 7. All right, so this one says, if a certain number is added to the numerator and denominator of 5/13, the result is 5/9. Find the number. So what is it that we're looking for here? Yeah, so they asked us to find the number, and this number that they're talking about is this number in the sentence. So I'm going to call that number X. And then we say, okay, well, they said if that number is added to the numerator and denominator of 5/13, so that would be 5 plus X over 13 plus X, because that's adding it to the numerator and the denominator. They're saying that that is 5/9. And so that would be the way you'd set it up. And then to solve it, you would multiply both sides by 9 to cancel out the 9s and the 13 plus X as well. And then you go through and solve it kind of like how we've been doing all the other ones. That would be the setup. Do you want me, and I can go through and solve
They
it.
also want to be 13. They want to be 13. Bracket and then
So you'd want to get rid of the fractions by multiplying by stuff that cancels out the fractions.
what do you multiply it by exactly?
By these two factors. Because like if you multiply by a 9, the 9s will cancel. And if you multiply this side by the 13
Why
plus
would you
X.
have said that? I didn't know if the 9 goes into the 13.
Oh, I mean, you could, but it's easier if you leave them separated because then you can cancel them out. Yeah. And so then once you do that, then these two will cancel out, and 9 times 5 plus X would give you 45X, or sorry, 45 plus 9X. And then over here, the 9s will cancel out, and 5 times 13, I think, is 65 plus 5X. And you'd get that. And this one's actually really easy to solve because you can just like, there's just a single X. There's like no X squareds or things like that. So you just subtract 5X, which would give you 4X on that side. And then you could subtract the 45, which would give you 20, divide by 4, and you get X equals 5. And if you take that answer and plug it back in, you can see that it makes sense, because if you add 5 to the top and the bottom, you get 10 over 18. And 10/18 is 5/9 if you reduce it. Any other questions you guys would like help with? Yeah, number 8. Okay. All right, so on question 8, we have that the current of a river is 4 miles per hour. So I'm gonna say river speed equals 4 miles per hour. A boat travels to a point 30 miles upstream and back in 4 hours. And we're asked, what is the speed of the boat in still water? So we're looking for the boat speed, which I'll call S. And we know that it goes 30 miles upstream and back in 4 hours. So I think one of the easiest ways to look at this problem would be to look at it in terms of speed. So we know the river speed, we know the boat speed, and the upstream speed and downstream speed are different. Because like if you're going upstream, you're fighting against the current of the river, versus if you're going downstream, it's backwards. So I would say the upstream speed is going to equal the speed of the boat minus 4 miles an hour, because the boat is, or the river is pushing back against the boat. Everybody good with where that came from? Okay, so the S is the speed of the boat. So the boat's going a certain speed in still water. So S is the boat speed in still water. But if it's going up against the river and the river is pushing back 4 miles an hour, it will slow it down by 4. And so then the downstream speed would be very similar, but instead of subtracting it, it's going to be adding it, because the river is like pushing the boat faster. Okay, so we know all of this stuff in terms of speed, but the information we were given with the 30 miles upstream and back in 4 hours, those are distance and time relations. So we want to relate these things two speeds. So what we would say is we'd say, okay, well, we know the formula that speed equals distance divided by time. But we can also write that formula as distance equals speed times time, right? Because you can multiply both sides by t. Or you could also write this as time equals distance divided by speed. All three of these formulas are communicating the same information. They're just solved for different variables. Is everybody good with that? Okay, so now we'd say, okay, well, we know the distance. The distance is 30 miles upstream. They go 30 miles up, they go 30 miles back. So the distance is good. And we know that the total amount of time it took to go upstream and downstream was 4 hours. But the thing we don't know is how long it took to go each part of the journey, right? Like we know upstream is going to take longer because you're working against the river, but we don't know exactly how much longer it is. So I'm going to write an equation where I'm going to say upstream time plus downstream. So I'll do a bold plus so you can tell it's a plus. Plus downstream time equals 4. Because however long it takes to go upstream plus however long it takes to go downstream, that equals a total of 4 hours. And so then you say, okay, well, how can I write upstream time when I don't know it? Well, I know that time equals distance divided by speed, and I know the upstream speed, and I also know the distance. So I would write my upstream time as 30 miles, because that's my distance, divided by my upstream speed, which is s minus 4. Then for my downstream time, I would again do 30, because that's the distance that they went downstream, but I'm dividing this by s plus 4 because that's the downstream speed. Is everybody good with that? And remember, this S is talking about the speed of the boat in Stillwater, but S plus 4 is the speed when it's going downstream. So that equals 4. Now we have an equation. So then you go through and you solve the equation. The number that you would multiply by on both sides to get rid of the denominator is going to be S minus 4 times S plus 4. When you multiply it by this fraction, you'll get 30 times s plus 4. When you multiply it by this fraction, you'll get 30 times s minus 4, because the s plus 4s cancel out, but the s minus 4 stays the same. And then on this side, you're going to get 4 times s minus 4 times s plus 4. And so you'll have to FOIL that out, multiply by 4, simplify that, and then you can solve for s. Now, because when you FOIL this out, you'll end up getting an s squared. So you'll have to do the factoring thing because one of your terms will have an s squared in it. So at the end of your solving process, you'll get 2 factors and 2 answers. One of them won't make any sense in the context of the problem. Like it'll probably be negative. And it's like it doesn't make any sense for the speed of the boat to be a negative number. And so in that case, you just eliminate the option that doesn't make any sense.